Recently, I came across this portfolio website that won Site of the Day on the 9th of June, and one section immediately caught my attention. It features a vertical spiral of images that continuously rotates in 3D. As you scroll, the spiral speeds up, slows down, and smoothly responds to your interaction, making the entire hero section feel incredibly dynamic. So I decided to recreate something similar using React and GSAP, and this is what I came up with. It has the same rotating spiral layout, smooth autoplay animation, 3D depth using scale and perspective, and scroll-controlled speed that makes the interaction feel really fluid. If you enjoy these kinds of animation tutorials and front-end effects, make sure to subscribe to the channel and leave a like on the video. Now, let's jump into the code. Inside app.jsx, things are pretty simple. We're just rendering the spiral gallery component. Inside the component, we start with a section element and attach a ref to it, which we'll use later with GSAP. It fills the entire viewport, centers all of the content, hides any overflow, and most importantly, applies a perspective value. This perspective gives our cards a true 3D look as they rotate around the spiral. Next, I create a wrapper that will hold all of the cards. I also enable Preserve 3D, which allows all of the child elements to keep their 3D transforms instead of being flattened. Inside it, I simply map over an images array imported from the assets file. Since the array only contains the image sources, adding or removing cards is as easy as updating the array without touching the JSX. For each image, I create a spiral card that fills the wrapper. I also enable Preserve 3D and hide the backface, so the cards render correctly as they rotate through the 3D space. The remaining classes are just for styling, adding rounded corners, a border, shadow, and making the cards look a bit more polished. Inside each spiral card, I simply render the image and make it fill the entire container while maintaining its aspect ratio using object cover. Before starting with the GSAP animation, let's import GSAP, use GSAP and the Observer, and then register them. After that, I create a ref for the main container. We'll pass this to use GSAP as the scope, so all of our selector lookups stay limited to this component. Before jumping into the animation, I create a ref to store a progress value. This value will control the overall rotation of the spiral, and as it changes, every card will update its position automatically. Inside Use GSAP, I select all of the spiral cards and store their total count, since we'll use both of these values to calculate each card's position in the spiral. Next, I define a few constants that control the shape of the spiral. The X and Z radii determine its width and depth, the height gap controls the spacing between cards, and the wave cycle's value decides how many twists the spiral will have. Next, I create an update spiral function. This function is responsible for calculating and updating the position of every card, and it runs continuously throughout the animation. Inside it, I grab the current progress value that we created earlier. As this value changes over time, the entire spiral rotates smoothly. Then, I loop through every card and calculate its individual progress by combining its index with the global progress. This keeps all of the cards evenly spaced while allowing the entire spiral to rotate as one. Using that progress value, I calculate an angle, which we'll use in the next step to determine each card's position in 3D space. Now we can calculate the actual position of each card. Using math.sine and math.cosine, I generate the x and z coordinates, which place the cards around a circular path. Then, I calculate the y position to stack them vertically, turning that circle into a spiral. Next, I add a bit of rotation so each card naturally follows the curve of the spiral instead of always facing straight ahead. Finally, I calculate a scale value based on the card's z position. Cards that are closer to the camera appear larger, while cards farther away become smaller, which helps create the illusion of depth. Once all the values are calculated, I simply apply them to each card using GSAP.set. Along with the position, rotation, and scale, I also update the z-index based on the card's depth. This ensures that cards closer to the camera are rendered on top of the ones behind them, making the 3D spiral look much more realistic. Now it's time to animate the spiral. Instead of animating every card individually, I animate the global progress value that we created earlier. As this progress value continuously increases, The update spiral function runs on every frame, recalculating the position of every card. This makes the entire spiral rotate smoothly while keeping the code simple and efficient. The animation repeats forever with a linear ease, giving us a constant rotation speed. Next, I use the observer to detect both mouse wheel and touch interactions. Whenever the user scrolls, I read the current playback speed of the animation and calculate a new target speed based on the scroll amount. This allows the spiral to speed up or slow down depending on how the user interacts with it. Then, I smoothly animate the timeline's timescale to that new value instead of changing it instantly. This makes the speed change feel much more natural. Once that animation finishes, I start another tween that gradually brings the timescale back to 1, so the spiral smoothly returns to its normal rotation speed after the user stops scrolling. Finally, I call update spiral once so the cards are positioned correctly as soon as the page loads. And here's the final result. Using React and GSAP, we recreated this interactive 3D spiral gallery by positioning the cards with simple trigonometry, continuously animating them with a single progress value, and using the GSAP Observer to smoothly adjust the animation speed based on user interaction. If you enjoyed the video or learned something new, make sure to leave a like and subscribe to the channel. Thanks for watching, and I'll see you in the next one.